this is our first problem. The cost of producing x items in one day is given by 0.00013x cubed plus 0.002x squared plus 5x plus 2,000. And this is like a factory equation. And so first we have to find c prime of x, which is also called the cost or the marginal cost function. To do that, we do our derivative rules. We multiply 13 by 3, 2 by 2, and then subtract 1 from each exponent, and then this will go away right here because there's no x value. And so you get c prime of x is equal to 0.00039 x squared plus 0.004x plus 5. Wait, can you see that? Can you see that? From the camera. Okay. Find the okay, and so that's your marginal cost function, and then to find it when 150 items are produced, you plug 150 in for x, and then add 5, and that's $14.39. $14.38. So that's what you get from there. Use a calculator, obviously. All right, and then C is find the cost function. You plug in 151 minus 150 of the original equation, and that is, what's the, Payton?
3,448.19.
Wait, 3,448.39.
Minus 3,433.75.
All right, and that is equal to 14 something?
0.44.
And that
is the actual cost of the making of the 100.
That is the actual cost of making the 151st item. So
the answer in B gives a good estimate.
So yes, and that means the answer in B is good. This is another problem. So we have kinematics. If the displacement S is given at the time t is given by the equation S is equal to 4t squared minus 3e to the negative 3t, find the time at which the minimum velocity occurs in the form ln of k, where k is a rational number. Alrighty, so first, I'm going to rewrite the equation. So we got S is equal to 4t squared minus 3e to the negative 3t. Alright, so to find S, or d of t, which is our first derivative, to find speed, or we take the derivative of this, so we do 8, oh shoot, that's about 8t minus 9e to the negative 3t. And then because the negative 3 multiplied by what is a negative 3, it's positive. So 8t plus 9e to the negative 3t. All right, so we want to find velocity, so we take the derivative again, which will give us dv over dt. And then again, we get 8, oh my gosh, my 8s are bad. 8 plus 9, which is 27, e to the negative 3t. Alrighty, and so that is our velocity. So we want to find that's our velocity function. We want to find the minimum velocity. So on a minimum, when you find a minimum, the derivative, or this function, is equal to 0. So you equal it to 0, and now we solve for t. So we got, I'm going to add, so it's going to be 8 is equal to 27e to the negative 3t. I just moved the 27e, negative 3t, over the other side. Then what we're going to do is divide this, or we're going to divide 27, we're going to divide 8 by 27 to get the e, negative 3t by itself. So we got 8 over 27 is equal to e to the negative 3t. Alrighty, and then because if you want to, because negative, you can take the inverse of it and make this a positive 3t. This will actually turn into 27 over 8 is equal to e to the 3t. Alrighty, and so now we are going to get the t by itself. So to get rid of the e, we have to take ln. And so then we have ln of 27 over 8 is equal to ln of e to the 3t. Yeah. Okay, and then this goes away, and so we have ln of 27 over 8 is equal to 3t. And then we can take this and go t is equal to, we divide it by 3, so you can multiply this by 1/3. So it's 1/3, and then if we reduce the ln, we get ln of 3 over 2. Once we, oh shoot, sorry, I messed up. So we go, it's still 27 over 8. And then when we multiply, or when we get rid of the 1/3, we multiply, we get t is equal to ln of 3 over 2 when it is, when the fraction is reduced. And so the time at the minimum velocity occurs from ln of k, where k is a rational number. This t is equal to ln of 3/2 minus 6x squared plus 5x plus 2 has a point of inflection. Find its coordinates. So the point of inflection, I have the hiccups. The point of inflection occurs at the second derivative. To find that, obviously, do the first derivative. So we have dy over dx. That is equal to 3x squared minus 12x plus 5. Alrighty, and now the d squared pi over dx squared for the second derivative, and that will be equal to 6x minus 12. That goes away. Alrighty, so we have the second derivative. Now, we set it equal to 0 to find the point of inflection. So if we set that equal to 0, we get 6x is equal to 12x is equal to 2. Alright, that is your x coordinate. Now, to find the other coordinate, we plug it in back into the equation. And so, alright, I had to make sure I got that right. So we got plug 2 to the original equation. And so we have 2 cubed minus 6, 2 squared plus 5 times 2 plus 2. That will be equal to our y value. Alrighty, so this is 8 minus, so that's 4. 6 times 4 is 24 plus 10 plus 2 is equal to our y coordinate. So we simplify, and we have 12, 8 minus 24 is 16 plus 12 is equal to y, and then we have negative 4 is equal to y. So those are our coordinates, and our final answer is 2, negative 4. Bang. That is the point of inflection. Yeah.
So in this question, we're asked to find all the stationary points. To do so, we have to find the derivative of this equation. then we have to set it equal to 0. So then we get so then we know our points are when x equals 3 and x equals -1. From there, we'll plug our x values back into our original equation to find what the stationary point is. Then we get this as our first point, and our second point